Yeah, good morning. So my name is Ben Hammond, and I work for a consulting firm in South Carolina. And for a long time, we've provided continuous monitoring data to local governments, cities, and around 15 years of that. And I'm not going to talk about any of that today, but something that I'm really unfamiliar with. So the idea was to come at APIs. So APIs are something that I'll speak on for myself, but we have avoided APIs in some ways, and we've even made some data management software decisions, and I'll end the majority of that because APIs were suggested as the way to get full functionality out of the software. We've come back and made better decisions since then, but this is a very elementary explanation of APIs. So if there are API experts in the room, this is probably not your presentation. But the experience really in the past has been some rigidness and some short-sightedness and really just not understanding APIs. And more recent experiences included a new generation of employee, and Alex Peavy, who's here today, helped put this presentation together, but I'd say it had an even greater impact on just forcing the issue and being a lot more open to new experiences in software that me at 20 years was just not necessarily willing to embrace. So the presentation is meant to be more of a practical discussion. The terminology will probably get muddled up. It might not even be accurate, and we can do questions and critique at the end. The way I approached it was more for just embracing the technology and the opportunities that are out there, and hopefully providing encouragement to one person in the room. And as it says in the presentation there, we were kind of forced into this, I feel like, at least in one of our offices. We have some other more progressive thinkers in our company. But the way that we got forced into this in our office was we deploy stations, just like you see on the screen here. And this is a stream bank installation, and we added a new device to this station. So we have the data collection platform where we are very comfortable with issuing control through direct connections to the equipment. And in this case, this bacteria analyzer that's deployed in stream, it'll collect its own samples and analyze them. It still takes 7 or 8 hours to do that. But we needed to talk to it and trigger that collection process. And so we didn't have a direct connection, but the manufacturer did offer an API. And so it wasn't overly complicated when we had to do it. And Alex figured this out in relatively short order. And to me, it kind of opened my eyes to this whole idea. So thrown into it, more or less forced to understand something that I'd avoided for a long time. And this is the analogy that I think it resonated best with me, and I saw it in lots of different places. But the API is, so in this example, the restaurant example, we are the patron, we are the client, the app, and we want to get something from the kitchen or the server database. And we need somebody to speak with the kitchen. We don't have access, or we don't understand the language that we need to get what we want from the kitchen. So the API serves as the waiter or waitress in this situation. And so for me, I started to get really clear on this, that the API is just a piece of software talking to other software. And maybe that's not accurate, so we can address that at the end. But I don't need to understand the server and database. So I have another slide to drive that point home. But I don't need to understand the server database side at my level of understanding. I just need to deal with the API. Again, I don't know if this is exactly the right terminology, but the REST and MQTT are API models, maybe, that I had come across, I'd seen for years. I mean, the last 5 or 10 years. And just wanted to throw these up there. It was more for me, again, to understand what applications we can use in this API world. And so my understanding is MQTT is good for, it's big in the IoT world. It's good for a one-to-many application, data dissemination. And then REST is a little more flexible and can handle larger, it can handle files and objects more than just data packages. So that's just a mention of, maybe it resonates with some of you seeing MQTT and not using it. I don't know. So when my daughter doesn't understand something, she says, "What even is it?" And that came to mind for me. So I'm trying to figure out, again, to simplify though, for me, I have to simplify in order to understand some things. And I forced that issue by cutting out the web server side of things. So now all I need to know is how to talk to the API. What do I need to send to the API in order to get what I want? I don't need to know about the back end. And then comes the specification. So, and as with anything else that we design or build, we're told how to do it or exactly what the methods should be. And an API specification exists for that reason. So again, this would be a hurdle for me to talk about APIs without some instruction would sound like an endless number of possibilities to make a mistake. And so the specification, once I was clear on the specifications exist, at least for a good API, that now I have some boundaries for what I can issue as an API request. And if it doesn't work, then there's probably a good reason for it. And let's go back to the specification and figure this out. But even this file here would cause me to stop. I would, in the past, I would not move past, I would not go forward. The different colored text, the tabs over, it's a YAML file. What is a YAML? And it is yet another markup language. It doesn't make any sense. It doesn't resonate with me. I don't follow. So, but there are other formats I learned that contain the same information and would direct me in the same way, but just in a different format. So again, for me, I'm looking for something that I do understand to move forward on something that I don't understand. And then the interactive application Swagger here is one, and I'll show a few others that we've dabbled in. But this would also help you understand the specification of a particular API. You could go through a trial and error phase and learn about the API that you're working with in this way. And I haven't said this already, and I guess, again, these are my elementary thoughts about the ideas, but the API has already stood up. Somebody else created the API. That was new to me. So we're not creating the API, we're just trying to work with it, right? So this is the instruction on how to do that. An API request typically include these 5 things, or most of these 5 things, I understand. So the endpoint is where we're going to get to the data. So to some web server, but then further than that, where exactly are we asking for? What part of that web server are we looking at to get data or post data? Right, so that's typically a URL address, or at least that's the ways that we've worked with it. API, some additional terminology, the method or the command. So we're typically doing something with the data or with that web server. We're getting data, we're putting data, we're posting or deleting in most cases. And that is HTTP commands language that a lot of folks already understand, which makes the REST model an intriguing model to use. It's something that most people are familiar with already. So we go to a place, the endpoint, we're using a method, and then the parameters, we have to issue some parameters for not all API requests, but some API requests, we have to issue parameters. And so the example that makes sense to me is if we're requesting data, if we're passing a query, then we would most likely ask for the start date and end date of that data range. And so those would be parameters in an API request for data. The headers, this is this nebulous world I still don't quite understand, but then in the header, there is information like the API key, if it's required. Not all API requests require a key, but the examples we'll go through do require a key. It's not that uncommon. And then that key is our authorization requirement. It can be in different formats. It can be a token. It can be a key provided by the API developer. And then the body is a place to also pass other information. And sometimes the parameters are passed in the request body. It could also be a query string. These are the platforms that we've dabbled in. Postman is the one that I prefer. It's just, but I guess the point to make here is there's lots of testing and implementation software. Finding one that you're comfortable with, that makes sense, and it could just be visually what makes sense to you or how you work within that application that allows you to be successful. And two software may do the same thing, and it may just be up to your preference. I included ChatGPT here just to make the point of programming. So I'm not a programmer, but I do a lot of programming. So just it's slower, but I understand that there's efficiencies gained through programming. So without referring to myself as a programmer, I do understand and know the need for that. And ChatGPT is an example of an AI product that can help you with developing scripts or programs to run API requests and routines to gain efficiencies. And ChatGPT is developed in Python or on Python? Anybody? It's trained on Python? Okay. So it's especially good at helping us develop API requests in Python. And it can be as simple as telling it what you want it to do, and it spits out the Python code that you run on some recurrence interval, and now you've got efficiencies built into your API requests without being a programmer. So we'll go through two examples, and they really tie together. And I guess depending on time, Emma, I'll get into more detail. But so a data query is a simple API request, and it's a practical application of an API. And so we host our data in the Eagle.io platform. So that's what we're using to display the data. But Eagle.io has also developed an API to allow folks to request the data outside of their user interface. And so we're using that API. We're communicating with that API to get data. And this is in our own data hosting application. So we're going to expand this discussion here to lead into the hardware control piece. But in this data query, what you're seeing is the endpoint, which looks like a URL with a specific endpoint being historic. So we're requesting historical data. And then the parameters that we're passing is the start time and end time. And all of this is specified in the API specification, right? So that slows my heart rate down a little bit when I know that there's a specification that's going to guide all of this information. So start time, end time, and the format that we want to receive that data in. This is another roadblock for me, this big long string, the params. Well, if I slow down a little bit and exercise some patience, then I'd realize that is something that Eagle.io provides. It's a unique ID for a parameter at a site. So this parameter is it's the turbidity data at a site we call Hudson, right? So it means nothing to look at right there, and I might just stop using APIs when I see this. Except that this information is readily available in Eagle.io, in the data hosting platform that I'm in every day. And I just got to drill down to find this unique ID. It's there, right? Eagle.io does require an API key that's provided by the developer, in this case, Eagle.io. So we have all the information to pass this request. This is in Postman. So now I just want to test this application. I want to test this data query. So I'm learning, I'm trying to understand APIs with great plans to use them in the future, right? So I go to Postman to develop this, to develop my understanding. And you can see at the very top, and I guess, I don't know if you can see it or not, but there's a URL up here that includes that historic endpoint. And then it's a get command, so there's a question mark there to indicate that it's a query. And then we start entering these parameters. And so the start time, end time, format, and params, it's the same thing that we showed on the previous slide. But then we're entering the information and we see this query get built right in front of us. And then we can issue this request. And you can see that there is a header for this one. But there's no body in this API request. It's all passed in the query string. Here's another way to do the same thing. So this is a portion of the Python code to do the exact same thing. And so we define some of these variables, but it's the same information, start time, end time. And this was this done in using ChatGPT? I think the bulk of it, right? So you can build this out using ChatGPT, the larger construct, and then if you have to make some tweaks, then certainly able to do that. So we build this request in Python, without being programmers. And Python has a request module. As you can see at the bottom there, there's a request.get. Right, so you have a module that's in Python code. Then you have the get method, which was specified on a previous slide. And then you issue the same command. So this is a little more challenging. I'm a little less familiar with this, but this is another day or two of training yourself to be patient can lead to some pretty good efficiencies. And then we get this. This is the output we asked for. We asked for all of that data. Now this is a different request for lots of rainfall data, but you get all of this data now in a CSV format. It's printed to your screen. You could extend this to save the file with a specific file name. All right, and then, okay, so what we just walked through was the left-hand side of this image. And so we have the Python script running. It is querying Eagle.io data on a frequency that allows us to very quickly assess if any of our in-stream water quality parameters have exceeded a threshold that we want to use to trigger an automated collection of a sample to be run through this Fluidian bacteria analyzer, right? So this thing will run on its own without needing anyone in the field to collect that sample. So we want to leverage this technology, but use the other to make this even more, to optimize the system. So the Python code is reaching out to Eagle.io. Did we exceed a threshold? If so, now we have to work back through the Fluidian API to tell this thing to take a sample, because we can't control it with a direct connection in the field, right? And so same process of reviewing the specification for this API, knowing what information needs to be passed in the request. And this is my format. This is the one that I can understand. It takes me still a little while to understand all of that, but to construct the API request, we can use Postman to demonstrate that we've got it right. Then we build it out in Python code. And similar to the previous Python code we saw, we're just defining variables. We're assigning values to these variables. And then at the very bottom, we're passing the request in the request module that's already in Python. So we didn't have to develop that. We're just using it. One of the things that we have to specify in the Fluidian API request is the label. And so we know that 3 out of these 6 samples were collected using the API request. So we got a trigger from a water quality value, a sensor value that was detected in Eagle.io API request, and then triggered the control of the automated bacteria analyzer. So I don't know if it's a whole lot of conclusions here, but more of a send-off or a takeaway. So if I was sitting in that seat, this is the kind of thing I would want to see. I would need to be encouraged to remove the obstacles. So I don't think the APIs are as complicated as I used to think they are or were. So I've had to slowly remove these obstacles, and with the help of Alex and just a different generational mindset about how to approach things like this, I've been able to remove some of the just really big hurdles that were not that big of a deal in the end. I do think the terminology is something I'll struggle with for a while, just parameters versus arguments. I think that a lot of this is the same thing. It's just what is the specification, what language does it use? And I do think it's helpful to find a platform that's good for yourself. It may not be the best for someone else, but if the ultimate goal is growth and understanding, then I think there's lots of options out there. And then if I put it down for 2 months and come back to it, in a lot of ways I might be starting over. So practicing and implementing these commands, even for simple things like we were discussing earlier, is something that I could do quicker in Excel right now. But or manual download. But if I really want to optimize the tools, I'm going to have to just practice and implement and not shy away from it. So I'd encourage you to do the same. That's all I have today. So. There is some time for questions. But I've already told you I don't know anything about it, so, but.
But I'm curious how you were convinced to get this talk. Like, you feel like like you know nothing. But for the record, you know more than me, and I appreciate what you shared.
The same time that we were starting to work with the analyzer there and realized we had to use the API, I think there was a lot of frustrations and stuff. There's not frustrations. It was frustrations on my part. I'm hearing, oh, you have to use an API again. And I'm sure I banged my head against the desk and thought, this has got to end, you know? What are we doing? But then it really was a lot of Alex saying, well, no, you just this, like it's just this, construct this. And we've been programming a lot for 15 years, just in data logger programs, and we had to learn that at some point. So he more or less convinced me that it's the same approach, it's just a newer thing. You have different responsibilities. And so one of my first slides was about delegating. So I got to watch him do it. And so at the same time, there was a call for abstracts. And I hadn't presented in a long time. And so I thought, well, this will be challenging for me to do, but that's kind of the point. Like he's convinced me that I can understand it. And now this is going to compel me to do it. Like I have to do it. So it's actually pretty simple. Okay. Yeah.
Sounds like you do this on a regular scale for time. What do you use to kind of initiate that? And like every 30 minutes, contribute again?
What is are we using task scheduler? Windows task scheduler is something that you could use to call, you could have a bat file that's used to call the Python code. And that's something that we've done for a lot of other applications, like where we're scraping USGS data to ingest it at sites where we have water quality data, but not the flow data, right? So we had been doing that for a long time, and that was part of the process. That was like, okay, connecting the things that we have done with what we need to do now. It's just different terminology in a lot of cases. So, okay, well, thank you for your time.
Thanks, Ben, for making that much more approachable than I think we all think about. Right. It's just happened to Ben. Let's close this. You want to save all the changes, right? Oh, I've never had much more trouble. PowerPoint.
It's as soon as you get up here that it happens. Hi, everyone. My name is Lindsay Platt. I'm an environmental data scientist with CUASI, which is the Consortium of Universities for the Advancement of Hydrologic Science Incorporated. And we're a nonprofit largely supporting students and researchers in the universities that are affiliated with us, but really to anyone, because all of our data infrastructure and education is free and openly available. And I wanted to give a little bit of context for this presentation in this setting, because I work often with students and researchers who are trying to publish data. And so I see kind of the issue of getting, okay, I've done my analysis part and I'm at that stage of publishing and trying to share this information. And there are a bunch of roadblocks that happen in that process. And so I've kind of picked up on some of the common things I see as challenges, and also thinking about when you're building your analysis or doing your analysis, some of the things that can catch you along the way there, and tried to package some of those ideas up into this talk. It says coding strategies, but there are a bunch of just kind of basic data best practice strategies in here. So if you're not a coder, much like Ben's presentation, do not shy away from my talk and what I have to say. I think there's something in here for a lot of different people. So the big thing that I'm going to say a lot is this idea of reproducibility. And I wanted to just take a moment to define it and really talk about why we even care about this. So okay, well, that's cut off, but it says same when you see this SAN, that's the word same. So basically, reproducibility is like the foundational concept of science. It's like you can give someone your methods and the data, and they should be able to produce the same results that you got. But that's challenging for a lot of reasons. And it's getting more challenging because we're all working with more and more data. A lot of our analysis techniques are becoming more complex, and a lot of us are working in bigger teams. So it used to be, you could largely work by yourself on something, and now we're just like growing in our collaborations. So it is tricky. And I just wanted to acknowledge that it's challenging, but hopefully there are some solutions in here. So if you're at my workshop yesterday, I like to use scenarios to illustrate my points. So here's a scenario. This little icon is my colleague Abner Bogan, who's also a data scientist at Kuwazi. And let's just imagine that you're sitting at your desk, you've finished a project, you're working on the next thing, and you get a message like this from him. And he says, oh, hey, there's one sensor that had an issue. I had to correct the data. That work that you thought was done actually isn't done. Can you redo this analysis? What would it take for you to do that? And now you're suddenly in this position of having to go back through and think like, okay, what did I do to get all of this? Some of it might be scripted. Maybe you have R code somewhere and you just need to remember which to run when. Maybe you found something kind of difficult in R and you're like, I'll just do that real quick in Excel. And you're like, did it in Excel real quick. Maybe there was some issue where you had a version of R that wasn't working for something and you outsourced it to a colleague and you said, can you just do this real quick and send me the data from that? And then now you're sitting there going, okay, I have to redo all of this. What were all of those pieces? And you just ultimately are like, okay, I'm gonna have to go back to square one, and I'm just gonna need to redo everything that I had done before. I am feeling physically stressed right now, thinking about having to do that for something that is done and that you thought was off of your plate. So even in the end, if you can recreate this, it takes tons of time, but you ultimately have the methods, and you can give them to someone else and they could reproduce this with the right documentation and code put together. Technically, that would be reproducible in the end, but I like to update this idea of what reproducibility is to include kind of the during the project aspect. So just like at the end, when you hand it off to somebody or you're publishing something in a report, your work should be able to be reproduced by you throughout the project so that when you hit these little things that are changes, you're not now sinking a ton of time into updating what you've done. So I kind of think of like you as an important person in this, and can you recreate the results throughout? And just starting to kind of chip away at what does it mean to be, to get to reproducibility, I think of this kind of tiered approach where the first part of it is just documenting everything. You don't need to be a programmer to document everything that you've done in order to hand that to somebody and have them also be able to do it. So just really investing in maybe writing more documentation than you think that you actually need. And then as your analysis may become more data intensive, you might need to kind of move to the next tiers, which are, start scripting things, make sure all of your data transformations happen in script or most of them. Maybe you're moving into version control, so using Git or GitHub or GitLab, GitLab. And then maybe ultimately you're working on automating all of this. And that was the workshop I gave yesterday, is on automating workflows through building data pipelines. And so let's imagine in that scenario, you actually had built a data pipeline, and a data pipeline uses this idea of dependency tracking where it links all of the steps in your workflow together so that when one changes, it will kind of cause the other ones in like a ripple effect to change. And so in the scenario that we were talking about, my coworker Abner had told me that one of the sites I had used was outdated and I needed to update it for my analysis. And this is a pretty simple example. It's very linear, but a lot of our work is more complex than the example here shows. But he told me that this is outdated. And so then when I go to redo this, my data pipeline knows what now is outdated because of that corrected data. So I'm not having to remember that. My code is now making those connections for me. And so when I go to redo this, and I'm showing in our example here, when I go to redo this, some of the pieces are skipped and some of them are rebuilt based on that change. So if I had implemented something like this and I got that message from Abner, I would feel a lot more comfortable to just say, okay, that's not a big deal because I can just pull in that new data and click run and things will just happen. Which feels really great because it is when you get to that state of having your workflows in that way, it's really beneficial. It saves you a lot of time, though you invested a lot of time to get there. And there are other benefits too. Again, I largely come at this from the kind of academic side, so that's why I say write papers faster, but really writing any kind of report or technical summary of what you've done becomes faster when you've documented things throughout and have the code all kind of there so you can revisit and see what the sequence was and the analysis that you applied. But much like Ben was talking about, it's challenging. It can be difficult to invest the time in some of these newer approaches because you probably don't have a lot of time to do the new thing. You know, you have a full-time job already doing a different thing. So yeah, it can be difficult to find ways to incorporate these skills and approaches into what we already do. So for that, I am going to start with just 3 small things that I think anybody could do, regardless of your current experience with coding. Maybe you do some of these things already, which is great, but just want to highlight these ones. So the first one, maybe it's kind of boring. It's about project organization. And there are 2 parts to this that I think about. And the first is literally folder structure. Truly, when I return to former projects and I'm trying to remember what I had done, if I had not taken the time to organize things, I am completely lost because I have no idea where the files are that I need, and I end up opening a bunch of things that I don't need to open in the search for something. So I follow this approach where I number, I kind of look at my project and I separate it into phases. And each phase gets a nice little action verb that tells me what is happening in that phase. So I used fetch and clean and model, but you know, you could use anything like download or something. But I also number them so that they have to appear in the order that they would be run. And then each of these kind of top level phase folders get subfolders where I'm specifying the files that go into this, that are kind of the manual ones I've put into this place, files that are created by my code, the actual code itself goes in that source file. And then sometimes they're just like intermediate things. You need to save a file, but it's not the final thing for that particular step. And then the other thing that I think about with project organization is file naming conventions. So the image on the left here is not even kidding. I've seen people and students in particular give me folders that look like this, where they've like made copies of things and they didn't rename them, or they're all named kind of similarly. And it just becomes really challenging to parse, like, what does this mean? And so simply just renaming, even if you don't use a full folder structure, just renaming things to kind of follow a very similar pattern, like, you know, you have the data, so I have like field raw data, field clean data. Those are following a very similar pattern. So the only thing your brain is having to pull apart is like, what's the difference between these raw versus clean? I often use dates, which is what those numbers are. It's the 2-digit year, the 2-digit month, the 2-digit day to indicate like certain dates that they were modified on. So that's in the file name and not necessarily I'm relying on the, you know, like Windows modified date as my only way of knowing when that was created, because oftentimes if you open Excel and you accidentally type a space into a cell and then you delete it and you exit, you probably click save and now the modified date is different. So anyways, I like to put some of that stuff in the name itself. And this makes it really easy to just quickly scan all of your files and know if you were searching for a particular one, find it and open it and not spend all this time opening every single thing. Okay, the other thing is about machine readable data. So I like Excel, but I also hate Excel at the same time because it's really familiar to everybody. So it's intuitive, we all use it. But it's also gives you like ultimate customized power. Like you can do whatever you want in an Excel file almost. At lunch yesterday, I was actually hearing some stories of Excel files that were like making my heart race, where people made like 1 billion tabs, and I don't know, there's some stuff that can happen. And then you inherit the stuff later and you're like, oh my gosh, I have to parse this file. So anyways, I just wanted to point out a few things. I say mistakes, but it's just like practices that make it difficult later to read it into a programming language if you do ultimately go into that space. So the first one is merged cells can become really challenging when you're trying to read in data into a programming language. You can just repeat that value instead of merging them across it. That's typically the approach. I often see people using color, which color is fine to use in Excel, but if it's the only way that you've encoded that information and there's not some other data that says why it's colored that way, that becomes problematic because the programming language can't tell what color a cell is in order to use that information. I've seen people give me files this way. Just be careful when you're mixing in a column if you're mixing the data type. So if you have numbers and then later on in that same column you have a character or something, like this can make it really much more difficult when you're reading the file in. You can get around a lot of this, but it's just more challenging. And then the last thing I will say is more of an opinion of mine and less of like you should not do this, but I don't like when there's contextual information in the same tab as my data, because what I like to do is pull that information out to a separate file and then have some other indicator in my data that will allow me to join those pieces of information together later. So this is kind of my view of what that file would look like instead. This is more machine readable. It's the same information, it's just presented in a machine readable format. So instead of having that site contextual information appear in like the header, I have the site as a column, and then in a separate file, I have that information about the site, and I can link those two in the future if I needed to. I put all of the units in the headers. That's a choice I made. And then those two other things with the merged cells and the color-coded cells, I added those as columns and I made them logical values. So it says true when it applied to those rows and false when it didn't. All right, my last kind of simple tip for reproducibility is about documentation. I think that there's people think about a lot of documentation when they're handing it off to somebody else, or it will be used by a group. But documentation is just as important for you as the kind of original creator of the information. And often I think of like future you as a collaborator that should be considered. I forget a bunch of things that I've done and have to come back to. So if I document it, it's good. So yeah, inline comments is important if you're writing code. Give people sufficient information to understand it. README files are kind of this idea of like when you come into a project folder, it gives you, it literally says README because the idea is that you go there first. And it gives like the high level introduction to what this is about and kind of like an overview of how you would get started with it. And then also something I don't think we do very often is have somebody else who is not actually in your project try running your code or doing some of the steps, or even just scanning it and reading it and telling you if they can follow it or not. The number of times where I thought I've documented enough and then realized somebody got stuck instantly is many times. So having somebody else just test it is good. Okay, I'm gonna go through this part a little bit faster because I was very slow at the beginning, but this next part is just some of the kind of more advanced techniques. So the first one I wanted to talk about is modularity of your code. This is kind of like, okay, now that you're scripting a lot, what do you do next? So you can take scripts like this, simple scripts that are reading in data. This is an R, fitting models, plotting it, and you can turn them into your own custom functions. So then once you have these custom functions that are basically just ways to kind of like collapse chunks of code and give them a helpful name, you can then take those and call them later. And it's a much like more condensed way to see what you've done. Yeah, it's just a little bit cleaner that way. And then you can also, so this is comparing the two, the script versus the modular version. You can also extend things when you've written your custom functions to be able to quickly apply them to new data, which is great. And then I mentioned dependency tracking already, that idea of linking your steps. These are a bunch of tools that can help you do it. So I'm an R programmer, so I use targets, but there are other things. If you're a Python person, SnakeMake is the tool I see. And to bring up YAMLs again, GNU Make operates off of YAML files. And then I did I gave a 90-minute workshop yesterday about targets. I've done it in the past too, and it's recorded here if you want to find that and follow along. And yeah, then my last thing is just that there are these like technical things that we can do, but there's also this kind of cultural part of moving towards more reproducible practices, or just kind of like data and code best practices. And the first is just like encouraging that work among our peers, talking about it regularly, testing each other's code, reviewing code, are all ways to like improve our skills. And then the last is, it's probably not a great time to encourage people to hire, but hiring data expertise in your groups, not just to do the kind of like tedious, like, oh yeah, I'll just hand them this terrible Excel file and they'll figure it out, but to actually like help guide best practices and a strategy for getting people to move forward on data best practices together is useful. Yeah, so thank you. That was a lot of information, so I would just close by saying, start small, create or organize your files, think about how you're putting your data together in Excel, and document your process. It's the way to start. Yeah, and I think we have questions because I was the last presentation. Thank you. The session runs till 10:30, right? Yeah. Oh, yeah. Ben has got one too.
What was the data flow that
Oh, yeah, for pipelines.
Yeah, so building a pipeline, that's something that restricts further progress through your code, or like how does that work with your code to interrupt the process really?
Okay, I'll explain. Yeah, I'll give another definition. So data pipelines, and I use SnakeMake as an example of a tool to do one. I use targets because I'm an R person, and Python scares me, but yeah, pipelines are a way where you have to write them as the programmer, I guess. It's basically taking your scripts and your code and bundling them into these steps. And then the pipeline says, okay, this step depends on these previous steps. Those create data that feed into this step, and it just, you can do that forever. And what happens is if you pull down new data and it's different than what it had used before, it will say, oh, okay, I need to now build all of the things that used that data, rerun them through these functions, rerun the model, rerun the plots. So it's a way to kind of, it tracks all of those changes and is forcing things to update when there are changes. Yeah.
So, just yesterday, I learned about targets.
Yeah.
Great workshop, look up the presentation in the YouTube recording. I feel like my personal journey with programming has been like, learn how to write scripts, learn how to write inline comments for scripts. Learn how to force myself to write documentation in like a literate programming style with, I'm not a person to like R Markdown or Porto or something like that.
Mhm.
And now this idea of data pipelines, where you're condensing, going sort of back just to the code, you know, probably documenting everything, you know, as functions, but how is there flexibility in these pipelines to allow for that literate programming style where you can write your novel about, I made all these decisions and then there's my code chunk?
Yeah.
Blend those methodologies.
Yeah, I think, well, one, pipelines can build the R Markdown. They're like steps, you can have it render the R Markdown for you. You have to think about, so that there's kind of an art to architecting them. So like, you know, it's not just like you say, hey, write this pipeline. You have to write the pipeline. You have to be the person doing that and making the decisions about how small or big to make each step. And so if your R Markdown file, your like well-described kind of file has a bunch of the steps in it that do really big things, like maybe it's like making a full plot or I don't know, cleaning up some data inside of that markdown file, the target step is really giant. And so it would rebuild more frequently than you might want it to, because it depends on a lot of things, but you can kind of prepare all of the things that eventually go into your markdown as steps and then pull those into it in a step, if that makes sense. So you can blend the two, but there is like a bit of an art to deciding the size of them and the benefits that you get out of it. It's one of those things where you just kind of have to start using it. And then you're like, oh, okay. I bet a lot of those words I just said were like, I don't know what that means, but yes, you can blend the two things. And when you start working in that framework, the targets framework or a pipeline framework, you start to then build this idea of like the right size to make the different steps.